You're watching the Jake Kaminski YouTube channel.
How's it going? I'm Jake Kaminski, continuing here with this bow tuning series that I'm working on. And today I'm going to be talking about rough bow weight, rough tiller, and then getting into limb alignment. What do I mean by rough bow weight and rough tiller? So as we go further on in the process that I've outlined in the overview video, the rough bow weight, I know what I want to shoot roughly. Okay, so I'm talking specifically when I take a bow out of the box. And you may be already limited to whatever your maximum bow weight can be, and you're possibly progressing up to shoot more and more bow weight. But for me, I know what I would like to shoot. So if I took my bow fresh out of the box, I would adjust and set my bow weight to be 46 pounds when the clicker clicks, something like that, right? So that's what I mean by I'd set my rough bow weight, because once the bow weight is set, then I've got to set my rough tiller and then, have a decent brace height in order to be able to adjust my my limb alignment. Now, what do I mean by rough tiller? Rough tiller basically for me is just get it close, get it within that 1/8 to 1/4 shorter on the bottom, that 1/8 to 1/4 standard split, and then we'll adjust tiller more fine as we go on, and we'll talk about that specifically as we get later on in this series. But you just want to get your tiller set to what your preference is. I know what mine was. It was 3/32 of an inch. I know it's a little shorter than 1/8 of an inch, but that just is what I preferred. So we'll get into, again, why or how to set the final tiller later on and what that affects. But for me, I just get it close, like I said, between that 1/8 and 1/4. Now, before I get into how to adjust your limbs, I just want to remind you guys that this is going to be a series. So if you wouldn't mind, hit that subscribe button and the notification bell to get notified every time a new episode is uploaded. I am also doing a form series as well. We'll talk about mental stuff. We'll talk about training as well, and other stuff, other series and other installments, how to pack for the sport, what to bring to tournaments, what to expect at tournaments, things like that. So there's a lot of stuff in the pipeline. And if you hit that notification bell, you will get notified every time a new episode is uploaded. And if you would, share this video to get the word back out there that I am involved in archery again. So I would appreciate that very much so. And I appreciate you guys watching this video now. So let's get into adjusting the limbs. So limb adjustment is very simple and standard. All you do is you adjust. So if you can imagine your riser is in the center and you had two limbs, top and bottom, right? They can be misaligned to each other, but then they can also be offset to one side or the other of the riser. So we're going to use the riser and the stabilizer as a reference point to get our limbs to be perfectly in line and in plane with the riser, so that way it's pushing the arrow straight and consistently time and time again. If you had the limbs misaligned, what that will do is you may have a tendency, like say if they're both misaligned to the right, they may have a tendency to kick your arrows one direction more so than the other. So that might mean that when you make a mistake that would send an arrow to the left, if your bow wants to automatically throw the arrow to the left, it may be less forgiving and throw that arrow further to the left than if you made a same mistake where you were to make the arrow go to the right. So the whole idea is to get the bow balanced and to have the top and bottom limb work together with the riser to push and deliver that arrow straight. Now, I like to use my stabilizer as a reference for the center line of the bow. I've had many people say they can use the center of the riser back here. Doesn't always work. Some risers have a line milled or machined into the center of the shelf as a center point, as a reference, but it's only one line, so you can't tell if you're slightly off to one side or the other. I have tried aligning limbs where I get my string in the center of the riser down here, and then I look at the top and bottom limb. And I find that I can get it close there, but then when I put my stabilizer on, my stabilizer can still be far off to the left or to the right. I see this all the time during the tuning seminars that my wife and I have been involved in, and we've been traveling around the world. So, by the way, if you're interested in a seminar in your area or have noticed that we are in your area, don't be hesitant to sign up for those. They are available to sign up at jakekaminski.com. I'll put a link not only here in the video, but also down in the description. But basically, I've seen people where they say, yeah, my limbs are aligned, they're straight. And we'll check, and yeah, it's definitely in the center of the riser when they look in the center of the riser. But when we put a stabilizer on, and it's a confirmed straight stabilizer, and their bushing is not machined or misinstalled, and the stabilizer is clearly off to one side, I adjust and bring the stabilizer back in, and then the string still sets in the center of the back of the riser. So what I think that's doing is it's just extending, instead of seeing something that is, well, down here, it's probably about 7 inches or so away from the riser to the string. When you extend that another 30 plus inches out here, if you're off a little bit at 8 inches, it can make a big difference when you have a 30-inch rod on the end of it. So if you use a 30-inch rod that you know is straight and use that as a reference, it makes everything just fall into place that much sweeter and straighter. Okay, so now you can understand why I use a stabilizer, but I want to show you it's important to not check your limb alignment with your full stabilizer setup assembled on the bow. The reason is that in every single stabilizer, there's tolerances. In everything, there's tolerances. So you have your stabilizer end cap that is glued onto the stabilizer itself. And then you have a hole that's bored inside the center of the end cap and then drilled and then tapped. And then you have this 5/16 24 set screw basically that is then also Loctited inside of the end cap. So everything has tolerances. If you had 1/1000th or plus or minus on every single piece here, you have not only the set screw itself, there's a plus or minus of a few thousandths, plus or minus of a few thousandths of the actual surface, the flat surface of the stabilizer, then the internal bore surface and the thread surface, the internal bore of where the end cap slides on, and then the OD of this stabilizer as well. Not only that, there's glue holding everything together, and you might have glue on one side over the other. So I found all the time that stabilizers can be bent, so can extensions, and also all the flat mating surfaces all have tolerances. So the bushing that is in your riser, there's tolerances there, but then you screw something against it, there's another tolerance. Then there's another connection here at the end where the V-bar bracket mounts on. There's tolerances there, the quick disconnect, the internal quick disconnects surfaces, and then the stabilizer connection surfaces. So in this particular setup, there is 1, 2, 3, 4, 5, 6 connections and 6 chances for something to be misaligned. So when I'm setting my bow up, I tend to remove as many outside factors as possible. So I will set up my bow with just my stabilizer and a straight stabilizer mounted directly into the bow itself. Okay, now I have my entire stabilizer set up off of my bow, and I'm just going to grab a random stabilizer and I'm going to show you how to check if your stabilizer is straight or not, so therefore if it's a good reference or not to use to align your limbs. If you don't have multiple stabilizers, I'm sure you have somebody in your area that also shoots that will loan you a stabilizer for a half hour or an hour or whatever it takes to align your bow. It's really important, and it's not going to work out. This whole system is not going to work out if you don't have a straight stabilizer. So a great way to check if your stabilizer is straight is to screw it into your bow by itself with the weight hanging down against the threads. So if I take this stabilizer out, I'm doing it down here with the bow clamped in a bow vise and stabilized on the floor just so I can really exaggerate this. But usually I just hold on to the riser and tighten it in by hand. So anyway, I screw it in a couple of threads, and then I let the stabilizer hang and preload down onto the stabilizer bushing itself. And then you want to hold your bow as still as possible, and then just simply screw the stabilizer in and pay attention to the end of the stabilizer. And you can see as I'm screwing this one in, it's not moving really at all. It's wiggling because I'm wiggling the whole assembly. But again, if I'm trying to hold it as still as possible as I'm screwing it, it's not moving in any fashion. Now if I take one that I know for sure is bent, this is a prototype with prototype end caps, so it's typical for me to not have straight stabilizers that are prototypes. Again, same thing, screw it in halfway, let it hang down one direction, and then now I'm going to screw the Stabilizer in, and watch the end here. And see how it's moving in a circle? So that means the stabilizer is bent to one side as I'm spinning it in. See? So this one's not straight, this one is. So as you can see, it's very important to not only have a straight stabilizer as a reference, but to put the stabilizer directly onto the riser itself. Do not give yourself or your equipment an opportunity to give you false information about your limb alignment. So this is a Last Chance Archery bow press. It's a power press actually, and they have a bow vise here that I use to clamp onto the stabilizer, or you could use something like this October Mountain Products bow vise, which has a really nice adjustable ball head, so you can swivel it any direction you want. You clamp your limb in here, or there's this nice groove, you just slide your stabilizer in there and clamp it down as well. So either one of these works really, really well. This one I just have set up on my my power press, so this is what we're going to use here. So you're going to notice that I am using a bow vise to hold the bow on the stabilizer. I prefer to use it that way. You can use a top tube clamp for a bicycle and clamp onto your stabilizer if it goes small enough. That would be a really good tool, and I always suggest to use those if you can. But the reason that I'm doing it this way is so the limbs are in free space, okay? If the limb was resting against something like the ground, it can actually affect the way you see alignment, because it could be bending the limb tip as it's resting against a table or something like that. So it's always optimal to clamp onto your stabilizer, clamp onto your riser, support it somewhere so that way the limbs are free floating in space. That is the optimal. If not, you can set it down on your limb tip, but just barely have it leaning against a table or a chair. You don't want a lot of side load deflection on the limb tip, because then it'll change what it looks like. Now comes a part that we're actually going to be aligning the limbs. These are the tools that I use. So I basically just use biter blocks. They're very simple. They're just two pieces of plastic that you can snap onto limbs. You can see how they have these type of serrations here. That basically allows you to snap it onto different limb sizes. I prefer to have quite a bit of clamping force to make sure it is centered on the limb. So if it's just barely on there and wants to fall off, all you gotta do, like people have a hard time getting it into the next step, you just gotta squeeze this opposite side like this, and it opens this side up so you can set it on the limb and then let it go. All right. So again, I use the biter blocks. I prefer the yellow ones like this. There is black ones, but I feel like I can see my alignment better. There's these two black lines, and the center of the two black lines is in the center of the block, which means it's the center of the limb. I've had some people ask me about I forget the name of it, but there's a new one that kind of adds a third dimension. It's like tuning forks. They kind of snap onto the limb, and then there's a piece that sticks further back. I'm going to show you why I don't like those. I think it's a really, really great concept, and it would be optimal in a perfect world, but we don't live in a perfect world. We live in the world we live in. So it's going to change things slightly. If you imagine that these are cross sections of limbs, a biter block would clamp and click onto it from this side, so it would have surfaces to touch on either side of the limb. A biter block clamps on this surface and this surface, and then comes out like this, and it has that flat piece, and these continue, and then you see your stripes, and you're looking from this direction. So there's two mounting surfaces that it touches, one on each side. The new limb alignment tool uses four surfaces because it's shaped like this. Whoops. It's shaped like this, where it touches the corners, and then it ends up coming together, and it has a central point that comes out and actually extends quite a ways. It extends maybe 3-4 inches. It's quite a long way. So it gives you a third dimension to reference against your limbs, which is in theory, again, great. But so we're taking, instead of two surface areas, that we have an opportunity of different amounts of clear coat to be on different sets of limbs, or having more clear coat on this side than this side. It happens all the time. And I'm going to show you how thick clear coat is and how much it can be different. So if we're looking at this section here, it's touching 4 points. So now we're, instead of just two different options or two different opportunities for different clear coat thicknesses, we've got now 4. And then we take it and we extend whatever difference that is and extend it out 3-4 inches. So if this one's a little bit off, it's going to push it this way more, and then this is going to go that way. So it's going to change a whole lot because of this third dimension. Whereas this 2 dimension is just going to be shifting this direction or this way, but it's not far away from the limb. It's actually very close against the limb. So it removes that third dimension, which I kind of like, because I can show you with multiple limb blocks, I can still show you the third dimension to make sure that the limb is in plane and going to pull back straight. This will do that with only 1 set, whereas I use 2 sets of biter blocks to align my limbs, so I have 4 total biter blocks on my limb systems. But I don't like the new limb block because of the magnification that can happen from different amounts of clear coat on different parts of the limb. And I'm going to show you here how thick the clear coat is on some of the limbs out there. All right, so I want to show you an example of how thick clear coat can be on the limbs. And they're sprayed by humans, not by machines. So it's very easy to have more clear coat on one side than the other. This is a set of limbs that I used, and as you can see, there's a difference in color between here and here. Here I scribed a line with a razor blade and then removed the clear coat on this side so it wouldn't wear down. And if I take a micrometer and I zero the micrometer, and then I use the depth gauge to basically put it near the on the area where there's no clear coat, and then push down and flat on the clear coat, and we can see it's 10 thousandths of an inch thick on one side. And I mean, it's going to change as I do it a couple times because it's not perfect. I'm again doing this by hand. That one is 11 thousandths, 11 and a half. It's the same spot, but anyway, this is on the other side. Let's see here. This is on the other side. And I'm getting, I don't know, what is that? 8 thousandths of an inch on this side as opposed to 10 thousandths. 8 thousandths. So again, I'm doing this by hand, so it's not going to be perfect, but you can still see that I've got about between 8 and 10 thousandths of an inch of clear coat on this limb. Let's check another limb. Make sure I'm still zeroed. I put it on the surface. This is 12 thousandths on one side. Go to the other side. 13 thousandths. So it changes. Again, I'm doing it by hand. It's not perfect, but you can see on average about 10 thousandths of an inch of clear coat on the limb surface. So if you're off by just a thousandth here and you extend it over a 4-inch length, if it's off on one side and it's pivoting over a 4-inch length, it's going to change what it appears to be, because it's very simple. You know, like I said, same thing. If you're checking the riser, the string on the riser as your center point, but then you have a 30-inch long rod and you use that as the reference, if you're just a little bit off here, you're off a lot out there. So same reason with this. If you're off a little bit here, you're off a lot where the reference is further out. Not only can clear coat be different in different spots, but you can have chips and dings in your limbs, especially if they're used. Like these limbs are used, and I have got dings up and down the edges of the limb itself. So, and especially on the corners where, again, those surfaces are from the new type of alignment tool. So I prefer to keep things super simple. Another quick thing to take into consideration is there's 2 main surfaces on a limb that will affect the alignment. So it's the contact point back here by the dovetail and the contact point here where the limb bolt sits. Those are the 2 spots that make all of the difference. And if, for example, you have something like this where you can see the clear coat has come off, if it's come off on one side, not the other, or differently on each side, it can change the way you're appearing, how your limbs look. So just keep in mind to keep an eye on the amount of clear coat that is on each side. And I mean, I'm not going to tell you this, but there's a reason that I cut that clear coat off where the mating surface is for the limb bolt. Okay, so now we're looking at the back side of the riser with the biter block on the top limb here. It's very simple. As you can see, the string here is in the center of the stabilizer. So you want to be able to see your stabilizer while you're doing this. Some people will stand too far back and then the stabilizer is hidden below the sight window so they can't see it. So you got to stand up close enough to the bow so you can see your stabilizer. And you want to center the string on your stabilizer and then look up at your biter. So I'm going to show you with using the camera on my phone, or just a regular still camera that takes still pictures. I'm going to show you how I use that as a tool to check my limb alignment, and you'll see in the pictures that I'll start putting in front of you. Now, as you can see, the string is in the center of the stabilizer, and you can see that both limbs are off to one side. Some people will mount a laser on the bow and use that, but I don't necessarily trust that the surfaces on the bow itself where the laser mounts, typically they screw to the sight bar or the sight window area. And if that's not machined perfectly flat and plain to the bow itself, if the paint is uneven or damaged, you're not gonna be straight with the center of the bow. So for me, I prefer to just take snap pictures and then look at them as reference. So how do you adjust the limb alignment? Pretty simple, especially on the systems that you can just adjust back and forth with Allen wrenches. The Hoyts with the shims are a little bit more labor intensive because generally you have to string and unstring the bow in order to access the shims, especially on the older models. But it's quite simple. So as you could see with the picture, there was a gap towards the left side over here. So it's really simple. All you got to do is move the limb to remove the gap. So on the bows that you adjust with shims like the Hoyts, move the shim towards the gap, okay? I'll explain that in a little bit here, but I'm going to work with this win-and-win system. There's locking bolts that you got to remove first to access the actual adjustment. Here's the set screws. This is from the win-and-wins again. It's again a collet lock that locks the actual system itself in place. So you got to remove these first in order to move the limbs at all. It's very simple to adjust the win-and-wins or any of the ones that have just these set screws. Now that I've had the locks removed, all I got to do is put my Allen wrenches in here. And there was a gap on this side, so all I'm going to do is I'm going to loosen the side that the gap is on and then chase it with the side that is going to be doing the adjustments. You don't want to back both off because then you lose the contact point on the actual pivot block, not the pivot block, on the block that holds the dovetail itself. So as you're pinching the dovetail block, you loosen one side to push it over with the other and vice versa. So I'm going to loosen the side that the gap is on just a little bit and then tighten and chase the side opposite the gap. As you can see, I have the top limb already adjusted. Now the bottom one, I need to adjust the same. So the gap is again on the left side. I'm going to loosen the left and chase it with the right. And then adjust that until I have both of my limbs in line. One thing that I forgot to mention was I mount my biter blocks at the base of the limb very close to the riser. This is especially important on the Hoyts with the pivoting limb block. It's because if you put them very close to the actual adjustment mechanism, it removes any sort of influence that the limb may be off this direction due to that pivot block. So with the block down here at the base, you won't see the misalignment down here because as you go further and further towards the limb tip with the blocks, you'll see more misalignment towards the tip. So now my limbs are adjusted, so I can take these lock screws and put them back in the adjustments, and I'll lock them down. But before I do that, I'm going to show you how to do the third dimensional plane view and see if your limbs are twisted per se. Not necessarily twisted, because again, there's a lot of mating surfaces within each bow and a lot of different tolerances. And so those can add up to be off one direction or the other. And that's where with the Hoyt system, you can adjust all that and make sure everything is perfectly straight. But as you can see, I have a biter block up high here and a biter block down low. Again, like I said, when you have one down here, it takes out any sort of twist. Up here, you will see all of the twist basically. So if you stand back and you look, you can center your string on this block and then check this block, and you'll see if it's off one direction or the other. This particular limb is straight and with the riser itself, and you can tell because both are in plane. You can also verify this using a draw board as you pull the bow back. After discovering doing it this way, I've realized you don't have to do that. Okay, now that we've aligned our Win and Win bow and I've shown you how to use their adjustment system, we're going to talk about the Hoyt adjustment system, both with the shims and the pivot system. So the pivot system this way, okay? This is a bow I shot at the Olympics, so it's already set up straight, but I'll take it apart and adjust it and show you how changes make a difference. So as you can see, the limbs are already in line, in plane to each other, and then they are also in plane the rotational way. This is your basic Hoyt dowel system. You can see it's an actual dowel that goes in and through the riser, and then it has the dovetail machined into it. And then on the other side of these two holes, there's two blocks that move in and out that can change the twist per se of the riser, or the limbs. It's very simple, very straightforward. On a right-handed bow, if this is the sight window side, so the open side of the sight window, this side, the left side on a right-handed bow, is the actual adjustment side. This is the side that makes all the adjustment. This side, which has the floating cap, as you can see, there's the Allen and then the cap itself, as opposed to the cap is solid. Or in older models, there's a side that you can't remove and there's a side you can remove. The side you can remove, or the floating side, is only storing extra shims. This side is the side that actually makes adjustments. When I'm talking about shifting a shim towards the side that the gap is, yeah, you don't have to always take one side and put it on the other. You can just add some shims, but it just keeps it easy. They come standard with 4 shims, 2 on each side. That's standard stock location. So if you're having a really hard time adjusting your Hoyt, go back to stock. Put 2 on each side, 2 10,000 shims, 2 full shims on each side. Your bow does come with half shims or 5,000 shims if you need just a little bit more. And I'll show you how to figure out if you have 5,000s or 10,000 shims. Okay, so I have 2 10,000s and 1 5,000 shim in my hand. I'll show you an easy way to recognize which is which. Older Hoyts came with brass shims. The brass shims are all 10,000ths of an inch thick, so that's a quick way to know for sure. Brass shims are 10,000ths. Now, in the old Hoyts, they came with extra shims and bags, not in the riser. Those are definitely 5,000ths shims. But if you have a new Hoyt, they come with stainless shims in both the riser and in the bags. The ones in the bags are 5,000ths of an inch, but this is an easy way to show you the difference between a 10 thou and a 5 thou if you don't have a caliper. So this is probably a 10,000ths, and you'll see it's stiff. It won't bend if I hold one side. But if I take the 5,000ths and I hold one side, you'll see it bend. See how much flex and bend I can give or make it have? Whereas this one's stiff. This is a 10,000th shim, this is a 5,000th shim. I call this a half a shim, I call this a full shim, because those are the shims that come in the risers. So now with knowing that, when I say 2 shims, 1 on each side, or 4 shims, 2 on each side, that means 4 total full shims works. If you have less than that, the dowel, the adjustment dowel, will clamp on itself and will float within the riser. You have to have a minimum of 4 total shims in the entire system for it to sandwich against the riser and align correctly. All right, so I put a shim in this pivoting system to throw the limb off. Right now I've got a total of about 10,000ths of an inch of shims in there, so there's 1 shim basically off. And you'll see that the top block is slightly off compared to this bottom block. And all that is there's a twist induced in the system that throws the limb tip off. And as you can see, the further out you go from the riser, the more you can see that influence with these biter blocks. So an easy way to tell what direction to adjust this pivot system to make this top block be straight with this bottom block, it's really simple. All you have to do is grab the limb and twist it one direction or the other. And it's kind of hard to show you here on video, but I'm gonna do my best. If this stays still, you'll see this rotate and change as I'm twisting towards the right. Now twist towards the left. And you can see that top block shifting compared to the string. So if it's out, right now there's that gap on the left side. So if I look at it and I twist it towards, if I twist the limb towards the right, it makes it worse. If I twist it towards the left, it heads the correct direction. So if I'm twisting towards the left, that's the correct direction. So what does that mean? That means I can push with this side or remove shims on this side. I always suggest to start with 0 shims on each side. Stock from the factory, it comes with 2 shims on each side. Sometimes they're not even tight. So from when you get your bow, even if it's fresh out of the box, I personally would remove all the shims, not in this stuff, but in this stuff. Start with 0 shims and then adjust from there. So that way you've only got a couple in case you lose some, and who knows, you never know. I just prefer to start with 0, and then, so for this one, in this scenario, because there's a gap on the left of this limb, I would push out on the right.
Thanks for watching. Be sure to subscribe and hit that notification bell so you get notified every time a new video is uploaded. For seminar and book info, head to jakekaminski.com or click on the link below. And yeah, I appreciate you guys watching. If you would, please share this video. It'd really help get the word back out that I am back out there. Thanks again. Take care.